topic is solving logarithmic equations. But first, making logarithmic equations like meaningful to you, you need to know definitions of basic exponential equations, which is f of x equals value of a to the x exponent. And always when you see like value of a, it cannot be less than 0 or equal to 1. So it always should be positive and more than 1. Solving Lagrangian equations. To solve Lagrangian equations, we write the equation in exponential form and solve for the variable. So like for this one, I don't know if you can see it, so I'll just rewrite it. It's natural log of x equals to 8. Let's just sit here. We all know that whenever you raise something to the exponential form, you always have to have the log base the same as the value. So we'll just rewrite it as e to the natural log of e, value x equals to the e of 8. Whatever you do to one side, you do it to the other side. So they cancel out. They cancel out, and you'll just left with x equals to e to the 8. And then you can just work yourself with a calculator, but it doesn't really matter. You can just leave it like that. Next one is remember that you will not always have log base 10. So, or natural log in your equation. Sometimes the base can be equal to 2 or 3 or whatever it is. So you need to find the inverse. So, for example, if you have log base 4, then you'll have 4 to the x. So we'll need to raise log base 2 to the 4x equals 3. We'll need to find the inverse of that base 2. This is too much. So, of course, it will be 2. And all of this we'll need to raise to the exponential form, which will be log base 2 to a value of 4x equals to 2 cubed. Then you'll just get rid of this log base 2. You'll be left with 4x equals to 8. And then it's easy, just work yourself up with the algebraic, it will be equal to 2. Right? This is just like some basic. What?
I had forgotten logs, and that makes it
It's
look
not
worse
worse.
than just saying.
So we can just like check or whatever we cannot, okay? But whatever I wrote on that side was under that yellow cover. And the same log base, the set of logarithmic equations have 2 logs, each having the same base, and you need to set them equal to each other and solve by setting the insides, the arguments or the values, equal to each other. So we can first solve log base 2 to the x equals log base 2 of 14. Whenever we have the same logs on both sides, we can assume that the sides will equal to each other. So we can just cancel it out again. It will be just left with x equals to 14. That's it. And then the same equation, but like a little bit more difficult, not as much. Log base b of x squared equals log base b of 2x minus 1. Can someone tell me what we should do here?
So x squared equals 2x minus 1.
And then just solve it by our equation, which will be x squared minus 2x plus 1 equals 0. Then you'll just get x minus 1 times x minus 1 equals to 0. You'll be just left with x equals 1. I have a question for you. If I would have in the answer here x equals 1 and x equals negative 1, which one will you choose? Or will you choose both for like x intercepts?
X equals 1. Can't be negative.
Yes. That's all we need to know for this. Then we have log rules. Those log rules are like you need to know because like it will be really easy for them to solve for the basic equations. The first one is log base b of m, and once you have a product, you can assume that it equals to the sum of those two variables. When you have a division, it's negative. And when you have something, a value of raised to an exponent, this exponent automatically just goes in front of your log, with whatever base it is, or 10 or 2 or whatever. So it will be rewritten as n times log base 10 of m. for an example that I have for you here, we will use two of the basic rules. For this one, we will use rule number 3. And for this side, we'll use rule number 1, which will be equal to 2 log base b of x equals log b of 4 plus log base b of x minus 1. So for here, we'll just go ourselves backwards. And we'll put this 2 to the exponent, which will be log base b of x squared. And for this side, because log base b and log base b are the same, and their sum will be just the product of each other, which will be log base b. And you don't need to write 2 logs again, because it's going to be just 1 log, which will be 4 times x minus 1. From here you just easily, again, just get rid of logs and solve everything algebraically, which will be x squared minus 4x plus 4 equals 0, x minus 2 times x minus 2, and your answer will be just x equals 2. That's it. And here is link for the course. Thank you.
Okay.